Thank you, everybody. Appreciate it. I know I'm holding you up from drinks, so let me quickly tell you a little bit about Splice Machine and first give a little plug to another talk here tomorrow that Gene Davis will be giving on Splice Machine's integration of the ML flow, which you'll hear in the keynote from Matei tomorrow. We've incorporated ML flow directly into our data platform, and that talk will be tomorrow at, I believe it's at 5:30, is that right, tomorrow? 5:20-ish, and you can check that on the schedule. So let me begin by just simply reiterating something that you heard in the early keynotes this morning. When you heard a little bit about Delta, you heard about the Lambda architecture. How many of you out there have implemented a Lambda architecture? Has anyone done that? A few people. And I think you heard everyone say nice things about Lambda, but sort of saying it was hard. And I think that we hear that all the time in the marketplace, that the Lambda architecture is just hard to do. And that's kind of why you hear a little bit about real-time transactional and ACID-compliant capabilities that are coming into the Hadoop and Spark infrastructure today. And the Lambda architecture is just basically broken because you had to duct tape the capabilities that you need for your operational workloads to the capabilities you currently use Spark for, which are your analytical capabilities and your machine learning capabilities. And it's really hard to keep the rearview mirror of the enterprise connected up to what you're doing in the moment through the windshield of the enterprise and to the GPS system that's kind of telling you what to do next. And so what we are here to talk about is a different approach to the quote-unquote Lambda architecture or to trying to be real-time. And we coined this operational artificial intelligence. And in my experience, I've started a few companies that have developed AI applications. I used to co-run NASA's AI lab. And in all of that AI experience, it has been ruthlessly dangerous in trying to keep everything duct taped together. And we started Splice Machine to try to fix this problem. And the whole idea is to seamlessly integrate what you would expect you need for operational AI applications. Of course, there's machine learning components. And of course, you need analytical components to build your pipelines, to do your feature engineering, to be able to provide the data necessary in a clean and legitimate fashion for machine learning. But there's always been this woeful separation from the operational workloads. And we think that needs to be very tightly coupled. And so we see operational AI as the seamless integration of operational intelligence with an operational database, an enterprise data warehouse for analytics, and machine learning models. And I want to contrast this a little before I tell you about Splice Machine's architecture and how we're attacking this. I want to contrast this with what you heard about Spark and the Delta Lake and Delta. And even Hive does a little bit of atomic transactional or ACID compliance. And how many of you out there actually have been exposed to ACID as a word or something that's good? So everybody in the room here is pretty much conversant in ACID compliance. But I think that our community has somewhat bastardized the term. And the reason why I say that is that it is one thing to take a big batch of data and be able to update a data store of that big batch of data atomically, but it's another thing to be able to literally operate an application concurrently where many different agents are simultaneously changing the data. In the first case, when you're just trying to do kind of data lake ingestion, where you're basically trying to bring a consistent view of external data into a data lake, you can do file-based ACID compliance like Delta. But operational AI is a little different. Operational AI is where you're making decisions in the moment, where what happens in the app a few seconds ago matters to the machine learning models that are being deployed or the analytics that are being deployed. And in order to power that, you have to use some of the properties and techniques that come from the traditional database community. In particular, you have to build an MVCC, a multi-version concurrency control mechanism. And you have to be able to do that at the cell level of a data structure, not the file level, meaning if you have tables and you have columns, you have to be able to track the individual changes that are taking place in specific rows and columns and be able to track that consistently with ACID properties. And that's precisely the difference between the Splice Machine approach to a transactional solution to solve this problem of the Lambda architecture versus some of the other techniques that you see in the marketplace. So how do we do that? We do that with a dual architecture. And that dual architecture has Apache Spark at the heart of it for analytical processing. It is exposed as notebooks, in notebooks for classic data engineering and data science. But it also has a full ACID-compliant operational RDBMS at the heart of it, so that you could literally be able to look up a single record in a few milliseconds based on an index on your table, or be able to change data with ACID properties being respected. And the way we do that is by also having Apache HBase under the covers of the architecture. And they've been integrated. Spark and HBase have been integrated seamlessly where you don't have to do that duct tape. And in the past, you always had to connect your NoSQL engine to your SQL engine and be able to, are you waving at me? No? Okay, great. You'd be able to connect up your NoSQL engine to your analytics engine in order to do this. Now, with Splice Machine, you actually just issue SQL to Splice Machine. If you're a Java developer and you're building an application with a web front end or a mobile app, and you need to have commits and rollbacks and multiple indexes, you use standard JDBC, ODBC, and maybe an ORM to access Splice Machine. It looks like Oracle or DB2, but at petabyte scale, because it literally is using the scale-out architectures of Spark and HBase. However, if you're a data engineer or a data scientist, just like on Databricks, you open up a notebook and you start writing in PySpark or in Scala and write your data pipelines and be able to execute your data science, but all on the same platform, as opposed to taking data out of one platform and putting it into another platform. So it's literally a Spark RDBMS. You can run your application on the same platform that you're doing your data science. In addition, and just a little plug for what's happening tomorrow, we've built a full machine learning manager in this architecture, and Gene Davis will talk about this tomorrow, where we've incorporated on top of our data platform ML flow and a few machine learning libraries, and the ability to literally manage your data science workflow on this operational AI platform. And perhaps maybe just to ground this in something real, and then I'll tell some stories about customers and how they use this. Here, and I know it's a little hard to read because it's a little bit of notebook code up there. One of the things that I think is unique is that we literally provide CRUD, create and update and delete operations on Spark data frames. So you can take a Spark data frame in a notebook or in a Spark app and literally with one line of code say insert, and that gets inserted into a transactional table without serializing that data across a JDBC or ODBC protocol. It literally takes the data frame and executes it directly into our engine. And the other side of that is you can also do updates and deletes and all the other operations you might expect. So the data scientist and the data engineer now has the power of a relational database management system literally at the same level, same semantic level as a data frame. And alternatively, if you issue a complex SQL statement, maybe a multi-way join, aggregations, groupings, and so forth inside of Splice Machine, that can be returned as a data frame, so you can put that into your MLlib data pipelines and so forth. So literally, the data engineer and the data scientist can use Splice Machine, even though it's a transactional OLTP database under the hood, they can use it directly in their data science and data engineering with the full power of Spark. Now a few stories real quick about how people consume Splice Machine and what are some of the first steps that they do. Sometimes people are simply replacing databases with Splice Machine because they're just too slow. We have a number of customers that have replaced Oracle applications or DB2 applications with Splice Machine, and literally their old SQL code will work. And that's the difference between Splice and perhaps some of the other SQL layers you've seen in the big data world. It literally is ANSI SQL that runs real transactional applications. In other circumstances, folks who have built data lakes, who have got data on data lakes, maybe using a number of different techniques to script the ETL pipelines that are necessary, are happy in the sense they've got a real-time pipeline. But many of these companies haven't been able to consume that data and use it to deliver business outcomes. Some of these companies now are layering Splice Machine directly on top of their data lake, providing a real-time SQL component directly on top of the data lake so they can build real-time apps on it. And lastly, for those that are leaping to AI and wanting to do AI applications but not really familiar with Hadoop or Spark or something like that, this is a fast track for those who are SQL trained and SQL savvy to build an AI application. So last story here is just somebody who's used Splice Machine for a highly transactional application. You guys all know how Spark works, and it works similar inside of Splice Machine, but here's an example of it actually performing transactionally. A credit card company, who is the largest credit card company, was looking at digitally transforming their dispute resolution process. This is the process that we all have to deal with when we see a credit card transaction that we're unfamiliar with, and we issue a case and dispute that particular transaction. Well, this company wanted to significantly reduce the amount of time that it was going to take to resolve those cases, and they had an inferior technology that wasn't going to scale. They had an old school relational database management system. They wanted to move to scale out, yet they had all of this traditional SQL that was transactional SQL that they wanted to be able to run. They tried to work with various operational systems that use SQL on a scale-out architecture, and we were able to convince them to use Splice Machine, and now almost every transaction in the world on a credit card streams onto Splice Machine seconds after you swipe your card anywhere in the world, and those transactions are available to every bank in the world to use in their dispute resolution business application that's been exposed to by the credit card company. So these are the kinds of applications that are out there where you typically see examples in ad tech and marketing tech where you're constantly getting ads for things that you just bought because the model doesn't know what happened moments ago. With an architecture like Splice Machine, it literally sees what happened moments ago. Another good example of this is an insurance company who literally had a business system implemented in SQL on a traditional database, but also had Spark models for detecting fraud in another part of the company, but they couldn't put it into use operationally because by the time the claims got to the Spark models, they didn't have all the data that was necessary, and the models, because of that latency of getting over to where the Spark prediction models were, made the scores inaccurate. But now, with an architecture like Splice Machine, an operational AI application, you now can run the business app and run your Spark-based models literally on the business application. So lots of business outcomes out there that can benefit from this combination of transactional or operational workloads, analytical workloads, and machine learning workloads. This has been recognized by various companies out there. Recently, Accenture has invested in Splice Machine and is bringing forth a Splice Machine practice around the world to deliver on this. Number of leading companies are using this, and we really appreciate the time that you took here today in listening to our story about bringing together operational workloads, analytical workloads, and machine learning workloads on one seamlessly integrated platform to power intelligent AI applications. So with that, I'll pause and see if there are any questions.
Unfortunately, we don't have time for questions, guys, but thank you very much, sir. Appreciate it.
Thank you very much.